Lesson 5.8 is about the rational zero theorem. So when they want you to list all of the possible rational zeros, all you have to do is take the factors of the constant and divide by the factors of the leading coefficient. So I'm going to make two lists. So the factors of 3 are 1 and 3. The factors of 12 are 1, 2, 3, 4, 6, and 12. All right, so then for your list of possible rational zeros, all you do is take the numbers on the right and divide by the numbers on the left. And you also put plus or minus in front. So the list will start with plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So we divided all of these numbers by 1, and now we have to divide them all by 3. So I'm going to continue my list on the next row. Plus or minus 1/3, plus or minus 2/3. I don't need to divide 3 by 3 because we already have 1. So next is plus or minus 4/3, plus or minus, we already have 6/3, and we already have 12/3. 6/3 is 2, 12/3 is 4. So we're actually done after 4/3. So here's our list. Okay, for number 2, again, all we really care about is the 4 and the 18. So the factors of 4 are 1, 2, and 4. The factors of 18 are 1, 2, 3, 4 does not go in, 5 does not go in, 6, and now we're going backwards. 3 times 6, 2 times 9, and 1 times 18. Okay, so for our list, we take all the numbers on the right, put them with a plus or minus in front. Then we take the numbers on the right and divide by 2. We really only need to do this to the odd numbers because we already have 2 divided by 2. So I'm going to take 1 and divide it by 2. We already have 2 divided by 2. So I'm just going to do this to the odd numbers. 6 divided by 2 is 3, which we already have. And 18 divided by 2 is 9, which we already have. All right, now I'm going to take the odd numbers and divide by 4. So we have plus or minus 1/4. Don't need 2/4. Plus or minus 3/4. We don't need 6/4. The last one we need is 9/4. So these are not all zeros. This is just the list of every possible zero. Obviously, at most, only 5 of these could work. All right, so this is going to be a long list on the right. Luckily, the leading coefficient is 1, so we really just need to write the list on the right. So plus or minus 1. I'll just go straight to the final list. Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6. 7 does not go in. 8 does. 9 doesn't go in because the digits add up to 3, but 10 does go in. 11 doesn't go in, and now we're just going backwards. So the last number we had was 10. 10 times 12. 8 times 15. 6 times 20. 5 times 24. 4 times 30. 3 times 40, 2 times 60, and 1 times 120. So again, we only made one list because the list on the right, we're just going to divide it by 1. Okay, the list on the left will be 1 and 5. The list on the right will be 1, 3, 5, and 15. So we have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. And then we have to divide some of those by 5, plus or minus 1/5, plus or minus 3/5. We don't need 5 over 5 because that equals 1, which we already have, and we don't need 15 over 5 because that equals 3. Okay, so now we're going to combine what we just learned with what we learned in some previous sections. So for number 5, we want to find all the rational zeros, and we want to do this without a calculator. So what we learned in the previous section, if I look at the signs, I have a positive, a negative. That tells me that there will be one positive root. And if I plug in negative x, all of the powers with an odd exponent will change. So the first term would become negative x cubed. This would stay the same. The next term would become plus 25x, so positive, and then a constant would stay the same. And now if I count those, I have 2 sign changes, which means the number of negative real zeros is either 2 or 0. Okay, and then using what we learned today, the possible rational zeros are plus or minus 1, plus or minus 2, 3 does not go in, 4 does. 5 and 6 don't go in, and now we're going backwards. 4 times 7, 2 times 14, and 1 times 28. All right, so now that we've looked at what we can guess, we know there has to be a positive. We're not sure if there's a negative. There could be 2 negatives or 0 negatives, so I would want to guess a positive. And it doesn't look like they skip any powers. All right, so looking at it, if I plugged in 1, that would not work. Right, 1 plus 4 is 5, minus 25 is negative 20, and then minus 28 is negative 48. All right, let's try 2. And I don't feel like doing 2 mentally, so I'll actually plug in positive 2 here. Okay, bring down the 1. 1 times 2 is 2. 4 plus 2 is 6. 2 times 6 is 12. Negative 25 plus 12 is negative 13. And it looks like this is not going to work. Okay, let's try another number. So again, I know there has to be a positive. So I'm going to keep trying positives. Let's try 4. And I'll do this a little smaller so I don't run out of room. Okay, bring down the 1. 4 times 1 is 4. 4 plus 4 is 8. 8 times 4 is 32. Then we get 7, and it looks like this is going to work. Our remainder is 0. And now we could write the depressed polynomial. The depressed polynomial starts 1 degree lower. X squared plus 8x plus 7. And we want to find the 0, so I'm going to equal that to 0. This is factorable. x plus 1, x plus 7. So we get our answers are, and I'm going to put them in order, -7, -1, and don't forget the one we just found using synthetic. X could also equal 4. All right, so it turns out there were 2 negatives and 1 positive. The degree was 3, so we have to find 3, and we did. All right, number 6. Now, what jumps out at me for number 6 is that factoring by grouping will work. So we learned how to guess when we can't factor. However, when you can factor, you should use factoring to save some time. So I could tell factoring works because of the ratio of the coefficients. I see a 1 and a 6. That's a 1 to 6 ratio. And 4 to 24 is also a 1 to 6 ratio. All right, so if I'm factoring, first group, I can take out x squared. Second group, I can take out a positive 4. And we're finding the zeros, so I'm going to equal this to 0. Okay, rearranging things, we get x squared plus 4, x plus 6 equals 0. So I have to solve both of these. I get x equals -6. And that's our only answer, because if you look at the directions tell us to only find the rational zeros. And these are not rational. So only rational 0 was -6. Another thing you could look at, so let's say you didn't notice that it was factorable by grouping. The signs in the original problem, they're all positive. And whenever there are no sign changes in the original expression, that means there are no positive real zeros. But then if you plug in -x, let's see, this would go to negative, positive, negative, positive. There are 3 changes there, so we know there's either 3 or 1 negative zeros, and we found 1 negative real zero. Okay, on the back, the only difference is now we're going to find all of the zeros, not just the rational ones. All right, so let's start with what we learned in a previous lesson. Look at the sign changes. Positive, positive, negative, positive, negative. I see 1, 2, 3 sign changes. So we have 3 or 1 positive real zero. Let's plug in -x. This would stay the same. This would become opposite. Next one, x squared would stay the same. X to the first would change, and then constant stays the same. All right, and we found that the number of sign changes there was 1. So we definitely have 1 negative, and the positives, we don't know. There could be 3 or there could be 1. The number of imaginaries, there could be 2 or there could be 0, right? If we have 3 and 1, then we wouldn't have any imaginaries. If we have 1 and 1, then we would need 2 imaginaries. All right, now what we learned today, I don't want to write out the list because it's a long list. Factors of 60 are the possible rational zeros. Positive and negative factors of 60. All right, so I'm going to start guessing. Let me write the coefficients. 1, 2, -11, 8, and -60. All right, now for guessing, I would probably guess positives because I know there's at least one of each. However, I know that there might be 3 positives. So because there may be more positives, it's safer if I guess positives. All right, so looking at it, if I plug in 1 plus 2 minus 11 plus 8 minus 60, that's not going to work. So we can try starting with a guess of 2. Okay. And it doesn't look like this is going to work. So now I'm going to guess 3 next. Okay, bring down the 1. 1 times 3 is 3. 2 plus 3 is 5. 3 times 5 is 15. Negative 11 plus 15 is 4. 3 times 4 is 12. 8 plus 12 is 20. 3 times 20 is 60, and we found our 0. All right, and then the other good thing about finding that 0, it looks like factoring by grouping will work. Our degree was 4, so we were at x to the 4th, and now we're at x to the 3rd. So looking at this ratio, or these ratios, they are both 1 to 5 ratios. So I'm going to write the depressed polynomial. It is x cubed plus 5x squared plus 4x plus 20. First group, we can take out x squared. Second group, we can take out a 4. All right, we can see that another rational 0 is negative 5. And if we solve this one, we get plus or minus 2i. All right, so all of the answers put together, negative 5, positive 3, which we found earlier, and plus or minus 2i. The degree was 4, so there should be 4 zeros, which we found. Okay, for number 4, I'm going to start by looking at the signs. So we have positive, 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 negative. That means the number of positives is definitely 1. Let's plug in negative x. Remember that odd degrees will change. So plus, minus, minus. There I see 1, 2, 3 sign changes. So there's definitely one of each, and there might be 3 negatives. So I would guess negatives. Okay, and we know they have to be factors of 54 divided by factors of 4. All right, so I want to save you guys some time in this video and just go straight to the one that works. After guessing a few, I found that negative 2 works. So let's plug that in, bring down the 4. Negative 2 times 4 is negative 8. 5 plus negative 8 is negative 3. Negative 2 times negative 3 is 6. 30 plus 6 is 36. Negative 2 times 36 is negative 72. 45 plus negative 72 is negative 27. Negative 2 times negative 27 is positive 54. And if we add those, we get our remainder of 0. All right, and again, we have good news. Grouping will work. I see the same ratio. If I multiply the first set of numbers by 9, then I will get the second set of numbers. All right, so the degree is now 3, 4x to the 3rd minus 3x squared plus 36x minus 27. First group, we can take out x squared. Second group, we can take out 9. All right, don't forget we already found -2 as a 0. Rearranging it, we have x squared plus 9 times 4x minus 3. So this is going to give us plus or minus 3i. This one is going to give us 3 over 4. So putting it all in one list, the first one we found was -2, then 3/4. Least to greatest is the preferred order, followed by irrational solutions. Okay, that is it for 5.8.